Indexes are important. Let's dive into the internals next on Tales from the Field.
Some food in you. Step 3, you grow hard about what you want to be. Step 4, everybody just do your thing.
Wake up, today's gonna be a good day.
If this is your first time finding your way over to Tales from the Field, give us a like and give us a subscribe. We have our community roundtable every Tuesday at 1 p.m. Eastern Time, live, but you can catch the recordings on our YouTube channel at any point in time. On Wednesdays, we drop our MS Tech Bits. That's one of those videos that you're watching right now. Okay, let's get on to the content. All right, we're about to get into the most controversial topic of SQL Server. It's more controversial than cats versus dogs. I'm cats and dogs because they go at it, they fight. I think they're hugging. You know what? It's not actually a fight. Heaps versus table is really just about knowing when you should use each one of them, understanding the internal structure. So what we really need to do is we need to understand how things work on the inside. So where do we store data in SQL Server? Well, we store it in structures called tables. There we go. We have essentially two types of tables that you're going to have in SQL Server. We have a heap and we have a clustered index. You're only going to have those two. It's never going to be anything in between. Each of them has their own purpose, and it's important to understand each of them. All tables are made up of pages. Pages are traditionally an 8K structure, 8 kilobytes that contain the actual physical data. And then we'll have other 8K structures that actually contain metadata to be able to help us find them. All pages are connected by an IAM page, an index allocation map. These are metadata structures that chain all of the pages in a table together. If you've ever written a select star statement and then you get back a series of pages and that gives you a series of rows and columns and data, that's why, because the database knows how all those pages are connected because they're connected by index allocation maps that make up a table. So heaps are an unordered set of pages connected by index allocation maps. Think of it like a really, really messy desk. Heaps are great for fast loading of data into them because they have very little overhead. You just slam the data in and it puts it wherever it needs to go, like plopping those papers on a desk. However, every time we want to read from a heap, we have to scan the entire structure. So imagine I've got a really thick book and I want to find one particular concept. I'm scanning through the whole thing every single time. Where do we use those? Most temp tables are heaps. Staging tables are heaps. There are good, valid reasons for us to utilize heaps. But if we want to use scan operations, this is where we need a clustered index. A clustered index is the opposite of a heap because, well, first off, it's ordered. And it's going to be ordered on the rows and the columns that we select specifically to go in the clustered index. We could have one. Most only have one, but you could have multiple columns. And one of the things we'll get into in the demo examples we do in our next video is that if I have multiple columns, if there's any duplicates, the clustered index will actually add a uniqueifier underneath the covers to it, a unique number, so that way it stays unique all the way throughout. So it's important to realize that the values, for us to be able to find this and for it to be a clustered index value, it has to be unique. And if we don't make it unique, SQL Server will make it unique for us. But before we get into that, let's talk about what we typically see. Typically, clustered indexes only have one column. We use a structure called a B tree. It's like a tree, but it's flipped upside down. The roots are on top. You can have many levels in a clustered index, but the top is always the root, the bottom is always the leaf, and any levels in between are called intermediate levels. The best clustered indexes follow a few rules. They are small, narrow, because we don't want them to be large in size. They are unique, static. We do not want them to change, and ever increasing in value. So that way they have a constant sort order that can be followed. Typically in SQL Server, the most common value that we find for a clustered index will be an integer value. If we know we're going to have more than 2 billion rows in a table, typically we'll go with a big int. 4 bytes for an integer, 8 bytes for a big int. And that keeps it to be very small, narrow. So that way we can search it very quickly. So to give a quick example of this, a clustered index is meant to be used where we have a where predicate value. So I'm going to use this value to look up and then return my data very quickly. Go back to the book example we had. Instead of flipping through the massive giant book, what do? I go to the back, I go to the index, I find the subject that I'm looking for, and it typically has a page number. I then go over particularly to those pages, and I can look through those and I can find the data I'm looking for. So in the example I'm going to give you, let's pretend I've got an index. I'm going to call this alphabet. My leaf level page is where all of the data is going to reside. The intermediate page is where my low levels go up next, and then my low values also are on the root page. And it's very important to realize that my low levels are what is elevated. So for example, if you look at my first intermediate level, my first values that I raise up are going to be A, C, F, and H. And then on the other side, I'm going to raise up J, O, T, and W. And then up at the very top, I will again raise up my low values. I will have A and J. So if I said select star from alphabet table where value equals H, I can begin to shortcut this. And instead of having to scan all the pages in the alphabet to find where H is, I just have to do 3 operations to be able to find the value I need. This is the power of a clustered index versus a heap. And this is why we use them. We use clustered indexes to be able to shortcut these operations. And that leads us to non-clustered indexes. A non-clustered index is an index that we can put on a heap or a clustered index. In some older versions of SQL Server, you have a limitation of 900 bytes. In some of the newer ones, you have 1,700 bytes that can make up a non-clustered index. But the non-clustered index structure is very much the same B-tree structure that we have in a clustered index. The only difference is the data level only contains the data that we contain in our definition, or if we use an include column, the include column is at that bottom level. But the data levels that we use in the definition are on the bottom level, the intermediate, and then the root, and we can search on those. The include columns are just the data we include at the very bottom of the data page, and we can get around the 1700 bytes limitation by adding include columns. All right, no demos this time around, but this video went long enough. So what we're going to do is in our next video, we will do some demos where we dive through the internals of heaps and indexes, clustered and non-clustered indexes. You know where we like to keep this going in the conversation down in the comments. So please sound off, and hopefully this was helpful. We'll see you next time on Tales from the Field. Thank you so much for joining us.
Good day, wake up. Today's gonna be a good day. Wake up. Today's gonna be a good